And good morning, Monday morning, you guys. So here it is, 11:16. Oh yeah. So what we're doing today is learning about a thing called, you ready? Logarithms. Ooh, sounds hard, doesn't it? But they're not. Just a big word, but it's not hard. Here is what logarithms allow us to do. Okay, if you have some x, let's say we've got, I don't know, any number like 5 to the x power equals, say, I don't know, any number, doesn't really matter. Let's say 100, okay? I'm just making up these numbers. How do you solve for x? Right? Divide by 5? Nope, that doesn't do it. Guess and check. You know that it's got to be bigger than 2. We know x has got to be bigger than 2 but less than 3, right? So it's got to be 2 point something. You can guess and check all day, but if we learn something about logarithms, it's going to teach us how to solve. So it's how to solve for exponents. So logarithms are basically going to be exponents. So here we go. So if we have a base like in here, like the 5 is my base, to an exponent, it equals some answer like 100, okay? So we can rewrite it. So we're going to take it from that form, like to b to the e equals a. It's just kind of like a side, a shorthand of that. We can transform that into log, just write log, L-O-G, log of the base. Now the base was 5, okay, the base was 5, so put down the 5 here. Of my answer is 100 is equal to x. Now some fancy calculators will actually do that for you. In fact, I don't know if mine, I've got one that will do it for me. Hold on for just a second. I think I've got a fancy one around here somewhere that will do it. Yeah, I think so. So logarithms, right? So if I go on my calculator, just showing you, I go, let's see, log, nope, that's not what I want. That's not the log, that's a different log. Math, number, where's it over here? There it is, log, base 5 of 100, boom, 2.86. Well, I knew it was between 2 and 3, so if I went 5 to that power, whoops, back up 5, to that power, what do you know? Okay, so logarithms are kind of handy. They help us solve for these things. So today, all we're going to do is just basically get used to logarithms, okay? So we're going to just go and manipulate these. So example A says, convert the following into log form. What does that mean? Well, we're going to take it from this form to this form. That's the base. So I'm going to go log. I want you to write log, L-O-G, of base 2. So the 2 is a subscript number. It goes like this. Of 8 equals 3. Okay? So I took it from the base, log of base, of the answer equals the exponent. Always equals the exponent. So B will do the same thing. I'm going to go log of base 10, right? That's my base, 10, of 100 equals x, okay? And now in this case, we know x has to equal 2, because we know that, well, 2 squared is 100, okay? Now, C, we're going to go log of base e of 2 equals x. But we're going to learn something new right now. That if it's log of base 2, remember we talked about e, that e is kind of like this number that's used in nature. We're going to rewrite that as ln, and ln represents, let me write that up here, way up here, okay? ln represents what we call natural log, okay? ln means natural log. So we're going to go ln, or natural log of 2 equals x. So these two are the same thing. So when you see log of base e, you just write ln. It means log of base e. So let's a little subscript on the side. We see ln, it means log base e. Okay, that's one of our little identities, okay? All right. And we could even use our calculator because we have an ln button on our calculator. We do. We've got an ln right there. I got an ln button. I go ln of 2, natural log of 2, and I get an answer about 0.693, blah, 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 okay? So if I take e to that number, I should get 2, shouldn't I? I should get 2. Well, what do you know? Okay, so logarithms are pretty handy. They help us solve for exponents, okay? Number 2 says we're just going to go the opposite direction. We're going to go from log form to exponential form. So The 4 here is my base. 4 to the x equals 16. Okay. Now, in B, if there's no number, the number's invisible. It's always 10. So that means up here, in this example right here, I didn't even need to write the 10, because if there's no number, it's implied 10. So let me write that down, okay? So log base 10 of anything is just log, okay? We don't have to write the base, it's log 10. And that's for obvious reasons, because we live in a base 10 world, because we have 10 fingers, well, thumbs, fingers, right? 10 of them, and of course we count in base 10, and we get this log button in our calculator right here. Log, that is base 10. So invisible base is always base 10. Invisible base is always base 10. ln is always base e, okay? Let's keep going. So if I do that, going back to 10, I'm going to set it equal to something so I have an exponent. I'm going to go 10 to the x equals 1,000. Well, x has got to be 3. In fact, I can use my calculator to prove that x is 3, because my calculator does logarithms. It does. Okay, so check it out. If I go log of 1,000, it's like saying 10 to what power? 10 to what power equals 1,000? 3. I knew that. Now see, we had just learned that there's an invisible base. We could rewrite this as log base e of x equals 4. Okay, so when we see just plain old ln, it's implied the base is e. Okay, so then, well, that's kind of smeared. Oh well, let's change it to exponential. Go the base e to the 4th power equals x. We're just going to go e to the 4th power equals x. And we can find out what e to the 4th power is. That's what Lauren asked on Friday, but let's just leave it as e to the 4 because it's an ugly decimal. Okay. All right, now solve each log. Well, one is to use a calculator, the other is use our brain. Okay, I'm going to use my brain because I'm smart, so are you. We could, if you had the special calculator, you could do it. But I don't have a special, well, you don't have a special calculator, so we're going to go 3 to the x power equals 81. So changed it to exponential power, okay? 3 to the x power equals 81. The base to the x power, okay? So then, I know already 3 times 3 times 3 times 3, or 3 to the x equals 3 to the 4th, right? Right? You agree with that? Or x has to equal 4. I screwed up, you guys couldn't see that. So I changed it. 3 to the x equals 81. And then from there, I knew 81 was 3 to the 4th power, same base, so x has to equal 4. Okay, b, let's set it equal to 0, because it's just easier if I do that. No, not just 0, I'm giving it away. I'm giving it away. I set it equal to x, so 5 to the x, okay, there's my base. 5, that's my base, to the x power of the exponent equals 1. Well, obviously it's got to be 0, because anything to 0 power is always going to be equal to 1, so x is equal to 0, okay? Now, c. Well, c. There's an implied 10, right? And in this case, 10 to what power equals 431? I'd have to guess and check, but why don't I just use my calculator? Hey, I've got this button in my calculator, and even on your phone, if you take a look at your phone and turn it sideways on your calculator, you go to your phone, you go to your calculator, turn it sideways. Come on, mine is it going to turn sideways? Maybe it's disabled. But you should have a log button in your calculator also. Calculator. I'm just going to use my fancy one. So, okay, I'm going to go, okay, what is? That's log, right? I'm going to do log. I see that? I'm going to go log. And that is base 10. If it's invisible, it's base 10. There's a base 10 there, but it's invisible. 431, and I get an answer of 2.63. So, 2.6344, blah, blah, blah. So 10 to that power is equal to about 431. But my answer is, just use your calculator. What is log of 431? Okay. Now, next page. Move along. Okay, now there's some rules. Okay, so one of the rules is that if you've got the same base to the same base, it equals 1. Okay, an example of that was if you have log base 5 of 5 equals x, or 5 to the x equals 5, it's got to be 1, okay? This one, the log of the base, Okay, so if I wanted to take and show you a rule of that, log base 5 of 5 to the x, we say equals x. Well, yeah, that makes sense because I would go change it to exponential. I'd go 5 to the x equals 5 to the x, which means it's got to be equal to x. Okay, so if these are the same, the base and the number inside, which would be your answer, it's just gonna cancel out and make the exponent. Okay, we know anything to 0 power is always 1, so log of base 1, you can even try to calculate log of 1. Okay, so if I go log of 1 is equal to 0. But you can't do log of 0. We're going to talk about that more, but you can't do log of 0. Log of 0 is not okay. It does not happen. Log of 0 is undefined. You cannot take log of 0. It's undefined, and the reason why is because no matter what you put up here for an exponent, it'll never equal 0. Never, never, never. So that is impossible. Okay, you cannot take the log of 0. Cannot. Domain error. Okay, we'll talk about that more. Okay, when we graph it. And finally, this one is just like this rule up here. These kind of cancel each other out, but you got b to the x. B to the x equals log base b to the x, right? And then you can just say that it equals x. Okay. All right, that is it. So 10. Let's apply this rule. Okay, same base, they cancel each other. I get a 3x. Let's use the rule. These two are the same. They cancel each other. Just 2x. Okay, this is ln of -2. I don't think you can do that. I don't think you can take. So the domain of all of these is x has to be greater than 0. I don't think you can do it. Natural log of 2, I think we're going to get a domain error, and I'm going to show you why in just a second. So if I go and do my ln of -2, I think we're going to get an error. Yep, error. It won't work. So no solution. Let's find out why this is true. All right? So logs and exponentials are inverses of each other. So let's graph y equals 2 to the x. Let me go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -1, -2. Okay? And if we graph just this one, it looks like this. And then 2 to the 1 power is 2, 2 to the 2 power is 4, 2 to the 3rd power is 8, 2 to the -1 power is -1 is positive 1/2, and 1/4. Okay, now what we notice is this. Super important. We talked about this on Friday, and that is there is a horizontal asymptote here. We talked about that on Friday, right? Okay, so there's a horizontal asymptote at y equals 0. Okay, now when you reverse all those points, check it out, because it's an inverse. So if it's an inverse, let's switch these points around. Okay, so that means we'd have a point in, oh heck, let me just write all these points out so you see them. Okay, these were my original points in red. We had a -2 and 1/4. We had a point of -1 and 1/2. We had a 0 and 1. We had a 1 and a 2 and a 2 and a 4. And we also had a 3 and an 8. Now, it's inverse. Let's switch around the points, okay? So I switch around the points for the inverse. Let's put those down. Okay, let me put that in a different color. Well, let's see. How about green? Sure, I got a green pen in my hand. Okay, so if I switch them around, I'd have a 1/4 -2. Switch it around, I'd have a 1/2 -1. Switch around because it's an inverse. 1, 0. Switch around because it's an inverse. 2, 1. Switch around, it's an inverse. I've got a 4, 2. Switch it around, I got an 8, 3. Okay, so if that's the inverse, let's check it out and see what happens. Okay, 1/4 -2 is like right there. 1/2 -1 is right there. 1, 0 is there. 2, 1 is there. 4, 1, 2, 3, 4, 2 is about there. And 1, 2, 3, 4, 5, 6, 7, 8. I guess 8's there. And then if I draw this in, it's going to look like that. That's the log graph. That is the graph y equals log base 2 of x. And the reason it's base 2 is because this was y equals 2 to the x, so base 2. Now, what do we notice? Well, I noticed that there is a vertical asymptote, and Lauren, you were asking about that. There's a vertical asymptote right there. At x equals 0, there is a vertical asymptote. Vertical asymptote. And if that's the case, then for domain, I see automatically that the domain is x is greater than or equal to 0. Now the range for this one is all real numbers. Okay, now the range is y equals all real numbers. Okay, anyway, we will work more with logarithms because they are super useful and handy for us. Okay, anyway, that's all I have. We'll talk again tomorrow.